Material legacies are any type of biological matter that are left in an environment after a disturbance occurs. These legacies can affect processes that are linked to community assembly and ecosystem recovery, and therefore affect the trajectory of the ecosystem after the disturbance occurs. Now, there are different types of disturbances that can either remove material legacies from the environment or leave them in place. And we ask the question of whether either type of disturbance creates more favorable conditions for the ecosystem to recover, or alternatively, cause regime shifts to alternate ecosystem states. On coral reefs, cyclones and hurricanes are a form of structure removing disturbance that kill corals and remove their skeletons from the reef. Now, this leaves the reef relatively exposed, which allow herbivores to remove macroalgae, which compete with corals for attachment space on the reef. On the other hand, disturbances that leave structure in place are things like thermal bleaching and predator outbreaks. Now, when skeletal structures are left on the reef, this creates refuge space for macroalgae, which may allow macroalgae to escape herbivory pressure. So we built a mathematical model of a typical coral reef that simulates the cover of live coral and macroalgae through time that grow either on exposed reef or within the protection of dead coral structures. We use this model to test whether either disturbance type can lead more to coral recoveries or trigger shifts to algae dominance. We found that if dead structure provides sufficient protection for macroalgae, this basically makes the algae-dominated state more prevalent even when ambient levels of herbivory are relatively high. Here are a couple time series that show on the left a structure removing disturbance and on the right a structure retaining disturbance, and these are at equal intensity. But on the left, when structure is removed, the system returns to a coral-dominated state, while on the right, when structure is retained, we see a persistent shift to an algae-dominated state. Now, we found this trend to hold true for most intensities of disturbance. So here in the top left panel, we see an initially coral-dominated state or system will always return to a coral-dominated state, regardless of the intensity of disturbance or the strength of algal protection. However, when structure is retained, there's a different story. In some cases, when algal protection is low and at lower intensities of disturbance, the system can recover. However, in most cases, the system shifts to an algae-dominated state. And this happens more readily as the strength of algal protection increases, as you can see with this black line here. Now, once the system is in an algae-dominated state, it's nearly impossible for it to return to a coral-dominated state. So in conclusion, we found that the structure-retaining disturbances diminish coral resilience by breaking a key feedback, which is the removal of macroalgae by herbivory, and therefore disturbances that create large quantities of this material legacy more readily shift the system into an algae-dominated state.